Hello and welcome to session 3 in our scientific inquiry program. I can't believe it is session 3. Where has
flown?
Time gone? It has flown by. And we have to say a massive thank you for all of you that have been experimenting with us. Well, almost, I know today's the day, who've been carrying on with us in classrooms across Wales. We have loved seeing what you've been doing, and we can't thank you enough for tagging us on social media. And we have a very lovely example of this now on the screen from e-sgol Cynod Sant in Maesteg, I think it is. They've been following along. You've got them there doing the equipment little quiz, lots of stuff. Hopefully you're finding it just as much fun as we are. Also, if you remember last week, the focus of last week was writing our method. Because obviously today's the day we will be using that method and we will be experimenting. And we have had a very lovely example, haven't we, Rhys?
We have. We've got an example here from Ysgol Llandeg in Cardiff. And you can see a lovely, well thought out method. It's step by step, it's numbered, it's very clear and easy to follow. Well done.
Handwriting is also beautiful.
Lovely. And also command words, which we emphasised last week. If you can use command words to start each point, each separate point, then it makes it much clearer for you to follow, and much easier to follow.
So thank you very much for that. And please keep doing that for the remainder of the sessions. So before we dive into today, like I said, I am excited. We'll be experimenting.
Excited.
I know. We must introduce our helpers for today. So we have in the studio with us, who will be experimenting with us. We have got some very, very lovely helpers here. Come on round. We're just making sure nobody trips over anything.
Here we go.
And give them a wave. We have got some lovely helpers here from All Saints here in Barry, so we are very much staying on trend and on theme for Barry. And you're excited to be experimenting with us in the studio today?
Yeah.
Fantastic. Now they will be doing basically everything that you guys are doing in your classrooms. So everything we work through today we'll be doing here in the studio, and we look like we're ready to go. What do you reckon?
Yeah.
Excellent. Right, if you go with Rhys over there for a minute. We will just have a little bit of a recap of what we are going to be running through today. So I mentioned already that we're just going to recap, as you've seen with those examples, we're going to just go over the method just to make sure that we know what we're doing. We are okay with all of the different steps that we're going to follow before we actually do the experiment. We will be here in the studio carrying out, as you will in your classrooms, our asteroids hitting the moon model. We will be dropping those balls into our tray of flour, so we can have a look at the effect or the impact those craters make. We will also, because it is very important, be collecting our results. Because if you remember from any scientific inquiries you've done before, it's really important that we keep a record of our results so that we can, next steps, write our conclusion. Working towards next week, we will be looking at doing some graph work, which is new for this scientific inquiry with us. And we will then, if you remember, just look at evaluating and tying the experiment all together. But that's next week. We're getting ahead of ourselves. Let's have a little look and remind ourselves of the method so that we know what we are going to be doing in this experiment. So as you can see up on the screen now in your classrooms, we've got the method that we wrote last time, clear, step by step. And as you can see highlighted there in all those different colours, our command words. So if we just pick out a couple here, we're making sure that we drop, that we measure, we prepare. Really important for this experiment, we're going to be repeating certain steps to make sure that we collect results for all of the different types of ball, all of the different types of asteroid that we are modelling here. And it's really important, stressing again how a method needs to be clear, concise, to make sure that we can all follow along and we're all doing the same thing, so that at the end we'll all be able to compare our results. So before we dive into it, we said it is very important that we need to be able to collect our results, which means we need a table. So what we're going to be doing first of all, I know, I may have said it about 4,000 times already to start our experiment. We need to be able to collect them and record them so we can use them to make our conclusions and, importantly, to plot our graphs next time. So what we're going to do just very quickly with you now, we're just going to go through how to create a table. So up on your screen there, you can see the basic outline of a table that we've drawn, that we've given to you. And we're going to give you a little bit of time in a moment, okay, to create your own. So how do we go about setting our results so that we can follow them easily? Well, you can see we've got lots of columns in our table there. And the first column will always have the same thing in it. In that, it'll always be the independent variable. There you go, as if by magic appeared on your screen. And the independent variable, remember, that's the thing that we change, that we are changing in this experiment, is the type of ball. So that's what we have put in that very first column. And you can see there we've got our tennis ball, golf ball, ping pong ball, marble. Now what we are actually missing in this table is we need 2 more rows, because if you remember, we said we're going to be looking at 6 different balls. And I think we can head over to Ree's table over there, if she's all set up, ready to do the experiment in just a moment. And we can have a little look. Where is she? There she is.
Hello.
The wave. What have we got over there, Ree?
So on my table here, I'm ready and set up for our experiment in a little while, but I do have all 6 balls here. Like Mel said, you need to add 2 more rows to your table for the extra 2 balls. So those balls here, tennis, golf, ping pong and marble. And then the extra 2, we've got a play ball, okay, and a bouncy ball. There we go. So those are our 2 extra balls, but you might have different balls, of course. Okay.
Okay, thanks, Ree. So whatever you have chosen as a class or as a group, however you've done it within your school, you need to make sure you have 2 extra rows at the bottom. For instance, on ours, we would put play ball and bouncy ball. Okay. So that is our independent variable, our very first column. What comes next, you might see actually there's not just 1 extra column, we've got lots there. But that's because for our dependent variable, the thing that we're going to measure, the diameter of our crater, what we need to do is we need to do some repeats, if you remember from our method. So you can see there we've got an overall heading, crater diameter, and really importantly after that we've got the units. So you can see that we are measuring our diameter in centimeters. We always put those in the very top heading of our table. And then we've got drop 1, or you could write turn 1, go 1, drop 2. I'm loving how I'm following them. And we've got drop 3 for all of the different repeats. So for each type of ball, tennis ball, we'll drop it once. We'll reset, we'll drop it twice, and we'll drop it a 3rd time. We'll do that for all of the different types of ball, all 6 of them. And then that very last column, which we're not going to spend too much time on just now, we probably won't spend too much time on it this session. We will make sure that we recap it at the end. But that is basically for working out our average. Okay, so what we'll do, and you can see the nice little sum there above, in order to work out an average, we'll take all of our different attempts, drop 1, drop 2, drop 3, we will add them up, and then we'll divide by the number of attempts that we did. So we're doing 3, so we'd add drop 1, drop 2, drop 3, divide it all by 3. Now, I should mention, because there will be some of you out here that this will be relevant for, there is something called an anomaly. What that is an odd result. You might find when you are measuring the diameter of the crater, or experiments don't always go to plan. Sometimes and through no fault of our own, sometimes we might not get the results that we're expecting. That's what we call an odd result, an anomaly. And if we find one of those, it'll be easy to spot in our table because it will not match the other results. So what we do is when we're working out our average, and like I said, we can sort that later, we would leave it out. It'd be easy to spot. Now, there is our table. And so therefore, it is time for you guys to have a go at drawing your table. Now, we are also, come on in, guys, here we go. We have our lovely helpers from All Saints. What they're going to do in the studio now, while you guys are doing this at, I nearly said at home, you might be in the classroom, is you will be, they'll be drawing their tables. Okay, they'll be getting something like is up on the screen right now, so that when we do our experiment in a moment, we'll be able to collect our results. You're going to have 10 minutes, okay, in order to complete your table. Do not worry if you don't finish in time. There'll be plenty of time to catch up, okay? We just need to make sure we've got somewhere to record our results. There's a little QR code on the screen. If you finish, you can take a photo of your results table, send it in. We would love to see these tables that you're drawn. And I think, are we ready to go? Are we ready to get our table sorted?
Yeah,
perfect. So over to you. Hello, welcome back. Should we give him a wave? Should everyone? Excellent. We have been working hard here in the studio. I say we. You guys have done a fantastic job of completing your tables. Did you get everything done in time? It's all right, wasn't it? Right, let's just have a quick look at some of these. You may or may not be able to see this as I show you, but these are some fantastic tables that have been completed. In particular, really important, we've got our centimeters up here, exactly just like on the table that's on your screen right now. We have got centimeters in our heading. Excellent. And then if we have a little look at this one here, we have included, again, you probably will not be able to see this, but we've got our 2 extra columns for our 2 balls, our play ball, and our bouncy ball.
Very good.
Fantastic job. Now, what I'm going to do is I'm going to ask you to take these and off you go with Ree, because it is almost time for you guys to complete the experiment for us. That's it. Excellent job. Okay, before we just show you a little reminder on how to set up the experiment, which is what we're going to do with our lovely All Saints pupils here in a moment. It's really important, okay, when we set you off to do the experiment, we would love to see any videos that you take. You might want to take some videos of the asteroids balls hitting the surface of the moon. Okay, as you can see up on the screen there is a little QR code with the Padlet. You can send in anything. It could be your completed tables at the end, any videos of you carrying out the practical. We would just love to see what you do as you go through this. So I think it's time to get set up. Now, for the purposes of us showing you it here in the studio, we are doing this on a table. Okay, which you may have spotted just now. We would thoroughly recommend that in your classrooms, you do this on the floor. Okay, we are speaking from experience because we have done this before, and we may or may not have made a little bit of a mess. We'll see how messy Rhea is over there.
I am quite messy.
She is quite a messy person, but don't worry, because she always tidies up after herself. So this is okay. Right. I think it is time. If we're ready over there, you're all good to go. Yes. We are going to get our experiment set up, and we're going to do this by following our method, which you guys will be able to do as well. So let's have a little look. Are you ready for step number 1? We are going to fill, there's our command word, the circular tray with 2 centimeters, about 2 centimeters deep of flour. So there we go. Good job.
All in.
Go on, tip it.
Go for it. Don't worry. If
we
you
already
make a mess, it's fine. There's a tablecloth. And
hopefully you guys have got some cloth on the floor in the classroom. If not, a dustpan. Excellent.
Go for it. More than there we are. Let's go for it.
I think we're just tipping the whole flour in. Ree's,
there we go. Yes. And that's brilliant. Go on then.
Okay, next step. Okay, and there's a couple of ways you can do this. We're giving it a little shake first of all, but step 2 in our method is we're going to smooth the surface over with a ruler. What we're trying to get to start with is the surface of the moon to be nice and flat. So Ree's just going to give it a little shake there, and then she's going to come in with a ruler. Here we go, just to make it nice and flat. So we've got a good starting surface for our craters to land on. That's great. You guys have done an awesome job.
Starting to look like the moon over here.
Excellent.
Very good.
Now, in order, obviously, to make it more moon-like, we are ready with step number 3. Almost ready for step number 3 over there?
Yes, we're almost ready. We're perfectionists.
I can see that.
There we go. There we are. Oh, that looks fantastic.
Right. Step 3 of our method. They're ready for it. I can feel it. Don't worry about that little bit of mess. I can see you, Ree. We're going to sieve. There's our command word. A thin layer of cocoa powder over the top of the flour.
Okay. Okay. So if you hold the sieve above the,
Good job.
That's it. Perfect technique. Look at this.
Now, the reason we do this, just in case you're wondering, the reason you could do it with just the flour, the reason for the cocoa powder is you're able to see the craters a little bit easier. When you put the cocoa powder on, you can Yeah, when you drop the balls onto the surface of the moon, you'll be able to see the craters.
Now that's give it a good whack.
Wow, good job.
Let's put some more on. Should we on the edges? There we go. So right around the edges. Oh, this is looking brilliant.
It's like a little cookery class going on over there.
It smells amazing, doesn't it?
Yeah, definitely no eating of the moon experiment, please.
Does it? Oh yeah, it's very nice sneezing though, wouldn't it be? Cocoa powder.
There we go. Excellent job.
I think that's fantastic. You've done a super job, Diane.
Okay, I think we are ready for step. No, I think you're just trying to make as much mess as you can, actually. But
I don't want to be left out here. I want to have a go. Is that all right?
I think we're ready for step number 4 in our method, and this is the bit where we're going to hold. There's our command word. Hold the meter ruler or tape measure, whatever you are using in your classroom, vertically next to the tray, making sure that one end is touching the table.
Perfect.
Now, this is why we said you do this on the floor, because thankfully we've got some nice tall people over there who will be able to, let's see that reach again, will you be able to reach up and drop the, yeah, perfect. But it's much easier if you do this from the floor, okay? So step number 5, whoever's doing this bit, hold the tennis ball. Here we go. Hold it 1 meter above the tray using the meter rule as your guide to make sure it is a fair test. Good job. Now you might want to come in a little bit. There we go. So that excellent. We're just trying to make sure, remember we said about those control variables, things that we keep the same. We're going to keep the drop height the same. So now our command word here, we are going to drop the tennis ball into the tray. Are we ready? Okay. 3, 2, 1. Woo! Did we make a mess? Okay, this is good.
It will come off. Don't forget, it will come off.
Now, what you want to do, step 6, remove the ball carefully. There we go. We can pop it back on its little stand over there. And hopefully we should see, it looks like a nice looking crater that you've got over there. Step 8, we're going to measure the diameter. Okay, we're going to, with accuracy with the ruler, you might see them deciding over there where they're going to measure from. Remember, you're looking for the outsides of the crater. Excellent. And what have we got over there, guys? What are we thinking? Yeah, 10?
10 centimeters.
Fantastic. And then record the data in your table. So if we want to record 10 in our drop 1. Now, don't worry, we're not going to do the whole experiment here with you. We're going to give you some time in just a minute to complete this practically yourself. But just to show you what we mean about taking repeats, if we go on to the next one, we're going to prepare the surface again with the ruler. So we just want to give it a little bit of a smooth out again, just to hide that crater, just to give us a little, yeah, it can just be a tiny little bit on that bit. Perfect. Good job.
Use the edge there. Oh, that's wonderful.
There we go. Excellent. And then our next step is to repeat steps 5 to 9 twice more so that we've got 3 sets of results for the tennis ball. So let's get that meter rule back in position, pop it up on the table. We're going to hold the tennis ball again. Excellent. I think these guys have done it before. Look at this experiment technique. Good job. And then 3, 2, 1.
Woo!
That was a good one.
That was messier that time, wasn't it? Fantastic.
Excellent. Look at you repeating the steps, and we're going to measure.
So do you want to measure? Use this one, the clean one. There we go. Cleanish.
They say clean. I'm not sure much is clean over on their table over there.
That way. There we go. There's 0, 2. Is that one there?
Around 7.
So 7. Should we say 7.2? Yeah,
oh, it's a bit smaller.
7.2.
Okay, throwing in some decimal places for us this time. Excellent work.
Fantastic.
And I think...
Do you remember what to do? Yeah. Okay. And then we're going to smooth it.
Let's go with drop number 3 for our tennis ball.
We'll leave a little astronaut there. Can watch you. He's enjoying his time on the surface of the moon.
Good smoothing.
There we go.
Okay, I think that's ready.
Pop that back down. They know what to do. They don't think they need the method anymore.
I think we can have a little cup of tea.
That's it. Perfect. So
3,
in a little bit.
2, 1.
Woo!
Oh, wow. Which one are we going to go for there? Always remember, when you dropped your crater, just be consistent with how you choose to measure the diameter of your crater.
It's a dirty one.
So here they go.
Oh, that's a clean one. Whichever one. They're both going to be dirty, aren't they?
7.
Do you think it's just under 7?
Yeah, like 6.9.
6.9, yeah. Excellent. Well
Very
done.
good work.
6.9. And well done. They're not writing centimetre in their table because it's already in the heading. So well done.
Excellent. So I think, well done over there. You did an excellent job. And I think not very much mess has been made. So you should be very proud of yourselves so far. They're quickly wiping themselves down over there. So now it is time for you guys to complete the experiment. We're going to do it here in the studio as well. We've got our golf, ping pong, marble, play ball and bouncy ball there ready to go. We're going to record our results in our table. You should have your tables that you have just drawn. If not, you can collect them as a class. Just make sure those results are being recorded so we can use them. Do not worry too much about the average column just yet, okay? Just get all your results in your table. We will deal with the average afterwards. And remember, we said there is a Padlet up on the screen. We'd love to see some videos of you dropping these craters. So anything you record, send it over to us. And you've got 20 minutes. Off you go. Hello, welcome back. Let's have a wave, everybody. Excellent. I don't know about you. You were probably having too much fun of your own, but we had a lot of fun here in the studio, didn't we? Did a lot of mess get made? There somehow, I don't know how, we might have some cocoa powder in hoods. We're not sure. There were some big impacts hitting the surface of that moon, weren't there? But you pretty much got on with it all by yourselves, really. I don't think you needed us at all. You were brilliant, weren't you? Did you have fun?
Yeah.
Excellent. And they didn't just have fun, they also collected some fantastic results. Now, up on the screen, you'll see there our table, which, as if by magic, was completed in real time by our lovely behind the scenes Hugh over there. And we've got, he's waving, we've got the results that they, our lovely helpers here, have completed. Now, I don't know about you, we had some interesting results there. You were very good at measuring the diameter of the crater. As we mentioned beforehand, don't worry if you had a double bounce every now and then. We had a couple of double bounces, didn't we? But as long as we were consistent each time with our method and where we were measuring from, then that won't affect our results at all. Now, I think we've got some interesting ones here, but what we're going to be doing in a moment is we're going to be looking at conclusions that we can draw from this. That's something that we're going to ask you to do by next time, is we're going to have a little think about which ball created the biggest crater, maybe which created the smallest, and how we can work that into a conclusion. So let's just have a little look at your results here for a minute, guys. Which one do you think, let's go, which one do you think was which the largest crater?
Tennis ball.
Tennis ball?
Yeah.
Tennis ball made the largest crater. And what about your smallest crater? Which one was that? Golf ball? What do you reckon? Maybe, yeah, I think maybe it was the play ball, wasn't it? Now, what do you think is the difference between the tennis ball and the play ball? What was different about them? Tennis ball was heavier. Good. We can use that for our conclusion. Definitely. That will have had an effect on why the craters were that size. Love it. Now, what we've started to do, and I said we would come back to this later, we didn't have time to finish, but what we've started is to work out our average. Now, you may or may not have come across averages yet, but what we're working out is we're working out the mean. Now, how we've done it, or how we've started to do this, is for each of the balls, for the tennis ball, for instance, our first value, what was our first one now? What did we get? 10. And then our second one was, no, it was hard work, that was 7.2, and then
6.1.
Excellent. And what we did, we took all of those values, we added them together, and then we divided by, how many times did we do it? 3. Very good. So we divided by 3. So our average, which you can see up there on the screen, our average for tennis ball was 8.0. 8.03 if you're going to 2 decimal places, but that may be a step too far. 8.0 for that one. And then for our golf ball, what was our first value?
5.2.
What did you get for the second one?
5.
And then, now, we don't think that's a big enough difference to count that as an odd result. So what we did again, in order to work out our average, is we added them all together and we divided by
3.
Excellent, they've got it. And our average for that one is, what did we get for that one? We got 4.4. Excellent, really good job. So as you can see, you may or may not have had time, hopefully you just had fun doing the experiment. Before next time, what we'd like you to do is we'd like you to see if you can work out the averages using that method. And what we'd also like you to try to do is come up with a conclusion. Now, you perfectly said just now, start of a simple, good conclusion. Just say which one created the largest crater, which was the
Tennis ball.
Excellent. And you might say which one created the smallest crater, which was our
Ping pong.
Oh, they were quite close, weren't they? I think we've got the play ball.
I think once they worked out their averages, they'll know exactly which one.
We only had time for 2.
Yeah.
So yeah, definitely the ball pit ball. It was very close with the ping pong ball though, because both of them are very excellent. And we can use that in our conclusion. What you might want to do in order to make your conclusion just that little bit better, you might say ways that you adapted the method perhaps, or anything you changed as you went through.
Yeah, because we changed the method a little bit, didn't we? We decided to add some extra cocoa powder midway. Why did we do that? Yeah, and we could see the craters, couldn't we? That was a really good addition. So well done you two for suggesting that.
And then a way to level up your conclusion a little bit more is you might want to say, you could include data, for instance. Now, this is something that even when you get to high school, secondary school, including data in your conclusions will become very important. And what it means is, rather than just saying the largest crater was made by the tennis ball, we can actually give the values with an average of, what did we say was the average for the tennis ball? Excellent. 8. What units would we use? What did we measure it in? Fantastic. An average of 8 centimeters. And the smallest crater was made by the play ball. Oh, we haven't worked out the average yet. We'll get on it in a minute. We'll do it. It's of around 4. What do we reckon? Around 3, 4. So that's a way that we could level up our conclusion. And there are some examples on the screen there of things that you can include in your conclusion, just as a nice, simple starting point. Because a way of maybe thinking about our conclusion a little bit more, something that we can do, and this is what we're going to be working on in session 4, is we're going to be looking at graph work. Because while we plot graphs, the table is great. It's a lovely way of collecting our results so we can see we've been able to spot odd results. But what we can do in a graph is we'll be able to spot patterns or trends, maybe things that we wouldn't have seen just by looking at the table. So by next time, what we'd really love, if you can, if possible, if you've got graph paper in school, fantastic, that's great. If not, teachers, you can find, we found loads of free printable downloads on the internet, online, and also just using
you can create your own even. You could create your own.
You could do that. Or the maths books, using the squares in there, often that's a really good starting point for doing your graphs. Now, what we'd like you to do, you can see on the little work window there, I don't think we've got, sorry, I've jumped around all over the place. On the little work window there, you've got some keywords that you can use. We've got the little QR code that you can hopefully send us in some of your any conclusions that you write, any videos that you've taken from today. And you may have seen flashing before your eyes there some of the cross-curricular activities that we left you with last time. There are some numeracy, some literacy, some digital. There it is. Just things to, level up, or if you have completed everything, which is amazing, by the way. These are just some activities that you can try just to, just to have a look.
If you've done everything else, then it's perfect for you to get on with some additional tasks.
Now, just to briefly mention before we leave you for this session, this experiment, this inquiry has led us really nicely to be able to incorporate the 4 purposes. Things that, for instance, if I ask our lovely helpers here today, how well do you think you worked as a team?
Good.
I think they worked very well as a team. From watching what they were doing, taking it in turns, taking responsibility for your own experiment. I saw Rhea at one point just step back and go, they don't need me anymore.
I could go and have a cup of tea. I could. Well done.
You didn't. But there's plenty of opportunity in that practical for you to have been taking responsibility for your work, changing your method.
Yes.
And all of these fall really nicely within the 4 purposes. We'll leave this with you. You will have a copy of this PowerPoint, so that you can work through and have a little look and compare and see whether you think that you hit lots of the things within the 4 purposes. And I think all that's left to say is we would very much love by next time for you guys to have written your conclusion. We would love to see. So send us in on social media, tag SparkLab, tag e-sgol, and
I want to see if we've made more of a mess than you. So if you could send us anything of your equipment setup and doing your experiment, we would love to see that. Yeah,
excellent.
Excellent.
So thank you very much, and we will see you next time for the final part, where we will let you know a little bit more about the extra challenge that we'll be doing a little bit later on in the year. So thanks so much. Bye.
Thank
Say
you.
bye, guys.
Bye.